Hi everybody, and welcome to the second day of our 4.3 and 4.4 unit on triangle congruence. Remember, in the last video or last week we did SSS and SAS. So today we're going to concentrate on HL. Just wanted to show this slide again. So remember, to prove two triangles are congruent, you can prove in like number one that every side and every angle are congruent. That was from 4.2. You can prove SSS from 4.3, that was in the other video. You can prove side angle side. Remember, the angle must be included, so between the two sides. That was in 4.4. And then now today, we're going to do what's called hypotenuse leg, or HL. That's also from theorem 4.4. Here's HL, hypotenuse leg congruence theorem. If the hypotenuse and a leg of a right triangle are congruent, then the two triangles are congruent. So realize, to have the word hypotenuse, a hypotenuse only exists in a right triangle. Remember, this is what it would look like. So if for this theorem to work, the very first thing you must have is a right angle. If you don't have a right angle, there is no hypotenuse, therefore you cannot use the hypotenuse leg congruence theorem. So if you're looking at this, we have to have a right angle. So to set this up, the very first thing to try to do hypotenuse leg is I might start by writing down 90 degrees and then label the angle. In this case, I could say angle C is congruent to angle F. And those are my 90-degree angles. And then I have to have the hypotenuse. Remember, the hypotenuse is the longest side of a right triangle and always across from the right angle. So in this case, I have DE is the hypotenuse and AB is the hypotenuse. So I could say hypotenuse, and I could say I'm going to go with AB, segment AB. So I started on the top and went down, is congruent to, then I'd start on the top and go down. So I'd say DE. And then a leg, notice a leg is just any of the other sides. So I need a right angle to have a hypotenuse. If I have a hypotenuse, I only need one other leg to be congruent to prove the triangles are congruent. All right, so then in this case, the leg would be AC is congruent to, and since I went from A to C, I'd have to go from D to E, sorry, F, D to F, so D, F. Don't forget your segment marks. And so now I have HL is proven congruent. I have a 90-degree angle, so I get a hypotenuse, and I have one other leg. So then I could say triangle ABC is congruent to, then DEF. Sorry, triangle DEF right there. So this is the hypotenuse leg congruence theorem, how you can set it up. And this works, if you look at it though, notice what you have in congruence. I end up having angle, side, side. So notice I went from angle, side, side. Now that normally doesn't work, or what I would rather say is side, side, angle. Normally that doesn't work, all right? But because I have a right angle, in a right triangle, if I know this side and this side, well, then these two, the other legs have to be congruent because, remember the Pythagorean theorem, a squared plus b squared equals c squared. Because I have this theorem, I can use hypotenuse leg as a congruent statement, and it ends up not being the side-side angle method. So it still works, but it has to be in a right triangle only. So let's practice all of them in a bunch of examples I have today. The rest of this video is just going to be me going through examples. I'm going to start with this one. Are these two triangles congruent? If yes, state why and write a congruent statement. If no, you can just say, we'll say no. But if I start working on this one, I have right here a side TV, says it's congruent, so I have a side. I could say TV is congruent to, and I went from there out. It looks like it's a right angle at V, but it is not marked, and I cannot confirm that it is a right angle, so I can't use it. But then I would have to go with TR, so TR is congruent. I then have segment VU is a side, so VU, and some of you might already see that the answer here, and that's going to be RS. Okay. Whoop, sorry. Yep, that's correct. Okay, sorry. And then now I have an angle at angle U and angle S, so angle. All right, well, look at that. That does not work. That's not something that works, and I don't have a 90-degree angle, so I would write no. I do not know that these triangles are congruent, so I don't need to write a congruent statement. On this one, first off, notice right away I have myself 90 degrees. All right, so I could say 90 degrees. I'm going to start with that. Now, sometimes if it's 90 degrees, it may just end up being that the angle's congruent, and it's not going to always be HL. But let's just work through this. Now, look at angle O. And at angle O, notice there's multiple angles. So I can't just say angle O. I have to be more specific. It's angle MON. All right, angle MON is congruent to, and I'll look at how I did that. I went from up, down, the long leg, then to the short leg. So to do the other 90-degree angle, I have to start, where's the long leg? So I have to go RN O for that angle. That's how they're congruent. Now notice this segment here is in fact the hypotenuse, and that is segment MN, segment NN, congruent to, so I went top to bottom on that one, so then I'd have to follow from bottom up, RO to make a congruent statement. And then notice that they both share this segment. So that segment is congruent. But here if I went from 90 degrees out, that's leg, and I'd say ON. I went from 90 degrees out for that triangle. So then on the other side, I'd have to go from the 90-degree angle out that way, which then that would mean I would do NO as my other segment. Then that answer is because I've gotten my 90 HL, they are congruent, yes, and then write my congruent statement, triangle. Now, here's one advantage of using three-lettered angles. I already have the three angles, the letters lined up. So I could say then triangle MON is congruent to triangle RNO. So there's a big advantage when you write angles using three letters. It gives you the triangle congruent statement already set up for you. Moving on to the next example, if you look right away, hopefully you can tell that in this problem there is a right angle. So I have that right angle, but then I would also have this right angle. Okay, so I could state at 90 degrees, I have a value. Now I cannot say angle M because there are three different angles at angle M. So I have to be specific per triangle. I'd have to say angle TMJ would be congruent to angle RMJ. All right, and then what I have is I have this segment is in both of them right there. That segment is congruent to each other. That would be a leg or a side. I could say that JM is congruent to JM. And I have no other information. I can't say that I guaranteed nothing else is marked and nothing else is guaranteed. So the answer then is no, these two triangles are not congruent, and I get to move on. All right, now this next example, right away, I'm starting off, I see 90 degrees, and I see 90 degrees, so I have my 90-degree angle is, in this case, now I could say angle J is congruent to angle D, or you could write all three angles. You could have written angle RJM is congruent to angle FDB with the congruent statements. I then have this segment and this segment congruent, and that would be the hypotenuse of that triangle, of both triangles actually. So I'd say RM. Notice I went top from over here down. I went above the 90-degree angle down to it. Is congruent to, and I would say same thing here. It'd have to be FB because I went from above the 90-degree angle down to it. And at this point, there is no other known information. I would need either another side to figure out congruence here, so I can simply say that these two triangles are not congruent, so no is my answer. So taking a look at this example, Notice I have actually it's the exact same triangle except added markings there, so I can follow that same concept. I went with by 90 degrees, so I could say 90 degrees, that would be angle J is congruent to angle D. Again, or you could do the 3 letters. This is then from above the 90-degree angle over to the side is my hypotenuse. So then RM segment is congruent to, and again from above the 90 over to the side, the segment FB. And now I do have another segment I have here. So I went from, if I go away from 90 back to it for my leg, that would be MJ is congruent to, away from the 90 back to it, BD. All right, so I have 90 degrees, I have a hypotenuse leg. Yes, they are congruent. My statement is triangle RJM is congruent to triangle, and it would be FDB is congruent. All right, going through another example on this in this video. Are these two triangles congruent? Well, right away, what I start off with is I have single segment. All right, so I have a side, so that's TS is congruent to, and I went from the inner triangle outward, so I go from the inner outward on the other side to make sure I have my congruence correct, TQ. I then have segment from S to R, so I have another side congruent, so SR is congruent to, I went from the red up, so then from the red I gotta go up, there would be QR. And then let's think about it. Isn't this segment the same for both? So I have a third set of sides congruent, and that would be, I think I went from blue down to red, so that'll be RT is congruent to. In the other triangle, from blue down to red is also RT. They are congruent. I have the side, side, side. So yes, triangle, I'm going to go TSR is congruent to triangle TQR. I have a congruent statement by side, side, side. All right, another example to work from. Here right away, I'm going to start with, I have this length AC is 5, and notice I have this other length as well that is also 5. So if they have the exact same length, then I can say I have a side congruent, and I'm going to go AC is congruent to. So I went kind of from, it looks like it's a right angle, but I can't say that this is a right angle. So I'm going from the looking right angle back to C. So that would be D over to F. So DF is congruent. I now have from A to B is 7, so AB. And then from D to E is 7, so DE. So side AB is congruent to DE. So sorry, segment AB and segment DE. And then on the third side, all right, I have from F to C, that distance is identical because it's the same distance in both triangles. And for the top triangle, I add 2 to that segment. However, for the other, that's the left triangle, I add 2, but on the right triangle, I add only 1. Well, that clearly means those are not a congruent segment because this distance from yellow, this whole green distance is actually shorter than this black distance here. So I don't have a third side, so the answer is no, they are not congruent. All right, moving on to this next example, our second to last one. Now this example does have a very small little trick to it, and we'll get to that. But let's first start by just taking a look at our picture. And notice right away I have a side right there and a side right there. So I have a side, and I'm going to start on the left. So I'm going to say DE was congruent to, so I went away from the marked angle towards it. So away from the mark angle towards it would be then FG. Congruent angles here. Now again, look at that angle. There's more than one angle at point E. So for the angle, I have to say angle DEG. All right, notice I followed the red line like I did DE up there. So I should follow that same thing, angle FGE for that one. And then if you look at the picture, notice that these two triangles share this segment. All right, so there's another congruent side. So I do have congruence, but let's write it out. I went from the angle away from it, so that would be EG. Congruent to, now the angle here is at G. If I start at the angle and go away from it, I would say GE is the statement. So yes, there is congruence. They are congruent by SAS. But let's look here. Is triangle DEG congruent to D and F? All right, is that true? So I had a D and an F, yes. And then you need to check here, look, E, did E go to E? No, look at E and G are the congruent angles. So that should not be an E right there. So the statement is triangle FGE. So to answer this question, is this congruent statement true? My mistake, the answer is actually no. And this is the correct congruent statement. All right, I know that seems weird, but let's look at that a little closer. So I'm going to first take this one here. I'm going to go triangle DEG, so DEG. And if I mark it side, angle, side, and then I'm going to make the other triangle, which would go like this. There's an F and E. And I have this side congruent, this angle congruent, and this side congruent. So if you take a look at it, E and G are the congruent angles, right? And if I follow the single mark, I go from the angle on the single mark to F. So from E, the single mark over here to D, right? So D and F correspond. And if I go from G and follow the double mark, I get to E, and from E to double mark, I get to G. So you notice the circles and the boxes are different letters. So that's why this statement is false, but this statement is true. So yes, they're congruent, but the statement was incorrect. So that's how you got to double check those corresponding angles and sides. Here's our last example. Now, I'm not going to go through this entire problem with you on this video because it's kind of lengthy, but I'm going to show you what the process would be. Now, if I have coordinates and I want to determine if two triangles are congruent, when I'm given coordinates, the only thing I'm allowed to notice is side lengths. So to determine if they're congruent, I have to use then S, S, S. Because I don't have any formulas or ability to find angles in this situation. I can only find the sides. So to prove SSS, I got to prove that all of them are congruent lengths. And to prove congruent lengths, I would need to use the distance formula. But I want you to be careful and watch how I do this. I'm just going to set it up. If this is true, AB has to match DE. So I would first take AB and use the distance formula to find it and get a number. And then what I would do is I wouldn't move on to BC yet. I would go to this, here's the separation of the triangles. I would go first find DE over here, find the distance between D and E. And if those two are both congruent, then I have a reason to move on. If I get AB is equal to like 8 and DE is equal to not 8, well then it's not worthwhile to move on, because if I don't have the first set of sides congruent, you might as well not go on to the next one. Next I would check BC and EF. So do BC equals, find that distance, and then do DEF and find that distance. Again, if they are both equal, then it's worthwhile to go on. And lastly, I would do then is AC. So then do AC, the missing side, with then DF. And if I get all 6, if I get the red to be congruent, the blue to be congruent, and the green to be congruent, then I would say, yes, SSS proves triangle ABC is congruent to triangle DEF. Okay? To save some time on this video, I'm not going to go through that. I made a second video that only has this example on it if you want to see more in depth how this problem works. But if this problem makes sense to you and you know what to do, go ahead and use it. If you feel confused, watch that other video, please. Here's your assignment for this one. Enjoy and good luck.